Okay, now we're going to look at a simple example of computing Gini index and entropy and log worth. Okay, so that's our first step, and here there are two possible values for target, which is the riding mower ownership, okay, and we have two predictors, income and lot size. Okay, so suppose we have the root node, okay, and in the root node, okay, the node at the top, you have the entire data set there. Okay. So what is the proportion of non-owner and proportion of owner, the two levels of the target, P sub 1 and P sub 2. There are only two levels. Then once we have that, then we can compute the Gini index and entropy. And for that, we have to have the frequency distribution table. So we can now look at a couple of pivot tables, one for each predictor. Okay, so let's use that. And the first predictor is income. Okay, and ownership. And we bring ownership here. So that gives us the frequency distribution for income. Okay. And it is already sorted in ascending order, which is good. So now let's do one more. Okay, now this one I'm going to put right next to here, so let's start from here. Okay, and we'll use the second predictor. All right, so now we have the second predictor frequency distribution, and we should be able to compute the probabilities and the Gini index from these. So the root node is, that's the top node, the entire data set. Then P sub 1 is G32 divided by I32. So that's 0.5. Okay. 12 out of 24. Okay, we have not done any branching yet. We are at the top node. So P sub 2 then is just one, since it's a binary target, the target is binary, so P sub 2 is just 1 minus that. Then our Gini index is what? 1 minus the sum of squared values of the probabilities. Right? So we have 1 minus P sub 1 squared plus P sub 2 squared. So that will give you the Gini index, which is of course 0.5. 0.5 is the most impure, so you have a maximum value for Gini index. Okay. Now entropy, what is the formula for entropy? So right here. So we have equal to minus, okay, then the two parts, each probability should be multiplied by the log of that probability to base 2. So each probability, so this means you start with the first probability, okay, B41 times log of B41, and we want base 2. Then repeat that for the second one, base 2. Okay. So we have the minus sign there, and then sum of all of those different products. So this will be like minus, and this part is the sum of P times log of P for each level of the target. Okay, so need to be careful. So So that would be equal to 1, obviously, right? We already saw in case of a binary target, so it will be log m to the base 2, m being 2, is 1 is the maximum possible value, which is what we have right here. You have a question? D41.
Okay.
So that's this one. 1 minus the sum of the individual p's, square of each p.